So we first talked about the mean of some data set as a measure of center. But another measure of center that you might be familiar with is the median. Now, when we're talking about the median, what we're talking about is another measure of center, right? Another way that we can describe the sort of middle of a data set. Now, the way that I think about this differently than the mean is I think of the mean as a sort of balancing point of the data set, right? Where the weight of all the data is centered on the mean, where the median is actually the center value, right? And that might not make a ton of sense. So I'm actually going to draw through this concept a little bit here on my iPad. And, right, if I have some number line, right, and again, we could be talking about average heights of Americans, perhaps, something along those lines, right? And I have, let's say that we have 1, 2, 3, 4, 5 data points. When I go to find my mean, right, the mean that I'm going to find is sort of a balance point of these data points, right? So if each of these data points had the same weight, right, you can almost think of this as sort of a teeter-totter, right? This balance point is going to be exactly where the weight is centered between the two items, right? And maybe I can actually, if we actually come up with a real data set, right, maybe we can make this a little bit more clear. Let's say that we have a data set that is 2, 3, 6, 7, and 9, right? So if I take this average, let's see, that's 5, 11, 18, 27 divided by 6, which is also, I can divide those each by 3. That's 9 over 2, which is equal to 4.5, I think is my average, right? So if I actually plotted these out, right, let's say 2, 3, 4, 5, 6, 7, 8, 9, right? Let me make sure I did that math right. 2 plus 3 is 5, plus 6 is 11, plus 8 is, or excuse me, plus 7 is 18, plus 9 is 27. I have 5 items, 27 over 5. Let's go ahead and say I had a 0 here as, actually that doesn't work. So let me right. You said this is actually 27 over 5. Right, and if I look at a calculator really quickly and I divide 27 by 5, this is actually 5.4, right, is my mean, or my x bar, if x is equal to my data set. So, right, my data points here, again, are going to be, looks like 2, 3, 6, 7, and 9. And then when I'm looking for my mean or my balancing point, that is right at 5.4, right? Or somewhere right in here, right? And I can see, right, these guys way over here, this 2 and this 3, right, they're so far out that they have leverage, right? The same way that a teeter-totter would work. And this is where this is going to balance out. Now, if I'm thinking about the median, I'm actually talking about the center value, right? Of the 5 numbers, we're talking about the number which is in the middle, right? In this case, that center value is 6, right? So here, right, 6 is the median, and 5.4 is the mean, right? So we see that these are slightly different, and you might say, well, what's the point of having two different measures of center? And what we can see is happening here is that the median can actually help us when we have a data set that has outliers, right? Specifically non-symmetrical outliers, right? In this case, we have these two data points over here on the left, the 2 and the 3, which are, you know, a good bit lower than the rest of the data set, and they're sort of skewing that average to be lower than maybe is actually true of the real data set, right? Maybe 6 actually describes a common value for this data set more accurately than 5.4 does, right? We just happen to have in our sample some outliers, right? So when you're talking about descriptive statistics, we might often use the median. So when we're finding the median, right, just like I showed here, right, in this 2, 3, 6, 7, 9, when we've got an odd number of values, right, it's pretty easy to pick out the median or the middle value, right? Especially when there is a small number, right? Only 5. We can just see it's the data point where there is exactly 50% of the data lies below and 50% of the data lies above this sort of threshold, right? So if we have a data set that has, let's say, 6 data points, right? Let's say I have this new data point, 6.4 in there, right? In order to find my median here, right, again, I'm going to be looking to subdivide or partition my data in half and find a point where I have, right, 50% of my data below the median and 50% of my data above the median. And I can tell that's going to be halfway in between these two values here, right? This 6 and this 6.4, right? So to find the median between those two, right, I actually take their mean, right? So find the mean. First, I add them together, right? And then I divide by however many there are, and I can see that this is 6.2. So the median of this data set, right, maybe we'll call this data set Y. So the median of Y is going to be equal to, right, 6.2. So this is how we can calculate the median with pencil and paper. Let's jump over back to my browser here, see what else this lesson has to say, right? It talks about the center number, and it gives us some equations to work through and actually find the index of that center value, but we'll work through that using Python in just a moment here. In terms of how we're going to use notation, right, you'll often see MED, right, just like a function name, MED with the name of the list in parentheses as a parameter. Sometimes you'll also see this spelled all the way out, median, like I just showed the median of Y on the iPad. Sometimes you'll also see it as X tilde. Now, right, let's go ahead and jump over to the next video and talk about how to find the median using Python.